Good morning. In this video lesson, we're going to talk to you about the Pythagorean Theorem. Our specific focus now is going to be how do we use the Pythagorean Theorem to find distance on the coordinate plane. So let's take a look at our objectives and key terms today before we look at the guided problems. Our first objective today is what we just discussed. We want to explore how the Pythagorean Theorem, that formula for right triangles, could be used to help us determine distance on a coordinate plane. Coordinate plane, we know, is a fancy word for what we've called a graph. That's this four-quadrant figure that lets us give x and y positions on the graph. Our second objective is the same as last week. We need to understand that the Pythagorean theorem helps us find a missing side for a right triangle if we know the two other sides. Let's take a look at our guided problems today. Both guided problems, the major goal is going to be, how do I find the length of a diagonal line on a graph? The key is the green quadrilateral is going to show us is we could make our own right triangle on the graph, and then we can find the length of the two legs to help us find the hypotenuse. Let me show you what I mean. Quadrilateral ABCD, this green rectangle here, is split diagonally by a red dotted line that connects B to D. We call this line segment BD, and we show that by putting a little line over B and D. So this is asking you for the distance for line segment BD, this diagonal line. We don't know that yet, but hopefully you know how to find the distance for line segment AB. That's the line that connects A and B. And hopefully you know how to find the distance for line segment AD, which is the line that connects A and D. Pause the video right now and try to work out what is the distance for the red dotted line. And to find that, you need to first know the distance for AB and AD. Welcome back. Hopefully after pausing the video, you filled out this table correctly. I'm going to show you how I would have filled that table out. The first thing I'm asked to do is find the distance for line segment AB. That's this line here. I could count, because it just goes straight across, I could count 1, 2, 3, 4, 5. It jumps by 6 units. Or the other thing I could do, I could recognize that A goes from 2 and 7 to B with a value of 8 and 7. The y value doesn't change at all. From 7, it still stays at 7. So if I did 8 minus 2, the x value at the end is 8. The x value at the beginning was 2. So 8 minus 2 tells me it took 6 units to get from point A over to point B. Similarly, we can figure out then the distance for line segment AD. It just goes straight up and down. We count 1, 2, 3, 4 units. Or alternatively, we could have done 7 minus 3, which would give us 4 units. The trickier question is going to be, how do we find the distance for line segment BD? I'm going to show you my whiteboard now so I could show you how I would find that. So we're going to flip the camera. We're going to take a look at my whiteboard now, and we're going to show you at the end of the day, if we go and use this Pythagorean theorem, how we can find the missing side length BD. So hopefully you saw a right triangle. We took that rectangle, we split it diagonally, and I'm going to focus on this right triangle. Let me full screen the whiteboard. I'm going to focus on this right triangle that sits right here. We see that right angle there. I know the distance from A to B. If I take a look back at my work earlier, the distance from A to B is 6 units. The distance from A to D is 4 units. So when we take a look at the whiteboard, this is 6 units. This is 4 units. And we don't know this side, which I'm going to call C. Why is it C? That's the long side of our right triangle. And I know the two legs. So at the end of the day, if we're going to use our formula, I know A is 6. I know that B is 4. And I don't know what C is yet. That's what we're trying to figure out here. So there's my formula. A squared plus B squared has to be the same value as C squared at the end of the day. I'm going to substitute the 6 in for A. That gives us 6 squared. I'm going to substitute the 4 in for B. That gives us 4 squared. And that still has to be equal to C squared. I would encourage you to draw this river every day. That keeps the left side, the right side of my equation separate, and makes it a little easier to work. And I put the equal sign on the river every time I do a new step. 6 squared, that means 6 times 6, which should give us 36. 4 squared gives us 16 when we do 4 times 4. That's still equal to c squared. And hopefully you're familiar now, the last two steps, add those squares up. 36 and 16 would give us 52. What is the last step that I need to do to solve for c, this unknown side? I need to get rid of the squared here. What's the inverse operation? Take the square root from both sides. The square root of c squared, the reason I did that square root is just c. That tells me c has to be equal to whatever the square root of 52 is. That's going to be our answer here. So I'm going to come back to my document now. I'm going to flip the camera again. And we now understand the distance for line segment BD at the end of the day is going to be a square root, specifically the square root of 52. I'm going to take a look using my calculator to estimate what is the square root of 52 equal to. And I see 7.2111. I'm going to cut that off at the nearest hundredth. I'm going to say 7.21 units long. Take a look at my right triangle. 7.2 units seems pretty reasonable for this red line. If AB was exactly 6 units, should be a little bit more than 6. That's what I see with 7.21. It's not too big, it's not too small. It seems like a reasonable estimate for that diagonal line. Go ahead. Oh, I did never flip the video. I'm sorry about that. So go ahead and pause this video now and try to find for the purple line segment x to y, what is the length for x, y? All right, welcome back. The whiteboard I'm going to show you now is a little messy, but we're running out of time. So if you take a look now down at my whiteboard, I'm going to flip the camera for you again. And I want you to focus just up here in this little bit of room that I can make on this whiteboard now. We know that from x to y, and let me full screen this for you. We know that from x to y, we want to know how long this is from x to y. So your job is to recognize there's a right triangle here. If I draw a line straight up and down and straight sideways, let me show you what I mean on the document today. If I draw a line straight up and down and straight sideways, then we can create our own right triangle here. And better yet, why don't I open the drawing and show you that? So if we open that, oh, we're not going to be able to open the drawing. So I know that its coordinates 3 and 8 for x. I know that y is 6 and 3. So we're going to go back to the whiteboard and show you how that could be finished. If you take a look at the whiteboard, we should know now that from 3 and 8 down to 6 and 3, we need to jump down by 5 units. It's 5 tall. And we need to jump across from 3 to 6 by 3 units. So hopefully if you see a right triangle that's 5 tall and 3 sideways, you now have what you need to find x to y. If you can't find the distance of x to y knowing the two legs of this triangle, you need to talk to me, a classmate, or Miss Stewart.